DevOps work. I work as a DevOps engineer at Xenonstack. I am working in a cloud ops team and my squad name is SRE. I have been given this opportunity to present my work, which I performed during my experimental Saturday. I am doing this work under the supervision of my head coach. Must be wondering what experimental Saturday is. Well, experimental Saturday is an initiative by Xenonstack in which we perform tasks that are different from weekdays that we perform for our clients. Since I'm in a DevOps world, there are considerably huge number of tools present in the market. I am working in one of the tools that is in undergraduate stage of CNCF. CNCF and Xenonstack are proud partners. The other day I was working for my client and I was working on a project that had a lot of dependencies. I had to install all the dependencies before the actual project would be done. If I were to run the same project on my colleague's computer, the dependencies has to be installed again. This is a problem that I faced and I discussed this with my head coach. He asked me to found the solution during my experimental Saturdays. Well, there could be many solutions to this problem. Like we can run an EC2 server on AWS and we can run all the dependencies in the user data script. But this solution is not ideal. This could. A lot of charges can be concluded in the monthly bill. Anything above T2.micro is chargeable by hours by AWS. So there is a better solution that we can have. The solution which I currently have is called ContainerSSH. ContainerSSH is a tool that is in undergraduate stage of CNC. Let's take a look at ContainerSSH and understand how it works. ContainerSSH is a tool that puts user into the container. It does not run a container, it only puts user inside of container. The user does not have to do any kind of configuration management or any kind of dependencies that they have to install. They are already inbuilt inside the container. Now, the only thing the user has to do is run a simple SSH command. The user will be given username and password and the IP to connect to the server, and just with a single statement, he can have all the dependencies that were required during the project. Before moving on to solution, we should discuss what prerequisites there are to use ContainerSSH. Well, there should be a VPN connection between the user and the organization. For VPN connection, one can install either F5 or Sophos. In this project, I have used F5 as my VPN. Now let's take a look at architecture of ContainerSSH. To start with, our ContainerSSH will be installed on a server. Now the server could be on a remote location, of course it will be on a remote location. Now this is a user. The user will simply type a command in their bash shell to connect to the server. Now the server has a server name or it can be an IP address. This can be a public IP address and user will have been given their username to connect to the server. Now after performing this command, it will prompt to a password. The password will be provided by the organization. User will simply run this command and will be dropped inside the container. Now what will be running inside the container? It will be having two kinds of servers and there will be a one backend. Now first of all, this server will be checking for the authentication of the user one. Let us suppose the user one types a wrong password or the password do not match its username. In that case, authentication server will respond to the server on which ContainerSSH is installed and will tell that user is not confirmed. After the successful authentication of user 1, the server will reach out to configuration server. This configuration server will have all the dependencies and all the code that is required for a particular environment. Now let us suppose there were some Python dependencies. Let's suppose there are pandas to be installed or numpy to be installed in a project. It will already have those installed in a container. Now, a user do not know what container is. It will simply land in an environment that is of Linux or of Windows, basically of Linux mostly. Yes. After the authentication of the user and configuration of the files have been installed in a container, the user will land in a container and will have all the dependencies. Now, talking about this server can be installed in 3 different ways as of this date. It can be either Docker, it can be run by Docker commands, as a container, and it can also be run as a Kubernetes application. In this Kubernetes application, ContainerSSH will run as a pod. Now, it can also be installed as a standalone system. After this architecture, I hope you are well understood about the architecture of ContainerSSH. Now, once again, let's take a look how a user will see this environment. A user will have its username and password. They will just point towards the server. They will give their password and they will simply land in a container. Now, this is just what user has to do. It has nothing to do with Kubernetes or containers. Just the prerequisite is that I have already told you that they should have a VPN connection to the server. Let's take a look at implementation part of this ContainerSSH. Now, step 1 would be to connect to a VPN server. In this example, I have not connected to VPN because my ContainerSSH is still running on my local host, so I'll be using that. So in this video, I'll be skipping step 1. Now, step 2 would be to have a username and password. Since this is a quick setup and a local environment, I am using foo or a replaceable name. Foo is a replaceable name in IT world. We'll be using foo as my username and localhost as my IP address or my server name. So let's look at this command. A user will SSH into their username and will have a server name. In this example, as I already told you, foo is a replaceable username and localhost will be the server name that will be installed. That will company will or an organization will provide. Now, what does this -p do? This is nothing but since we are running in a Docker environment or a container environment, we'll be exposing our port number to 2222. So this is nothing, you can skip this part. So this is what a user have to do. Now, after that, it will be prompted to have a password. For this example, we are using a sample password and we'll just put it over there. Now, after this, it will take some time to pull all the configuration file that is present in the configuration server and will authenticate. Around 10 seconds would be the appropriate time, I would say. A user is landed in a Linux environment. I have shown in this example the container number. This is root at this container ID. Now, I have used this command ls-al. It will list all the contents in the current folder. So yes, we have achieved what we wanted to achieve. A user is inside a containerized, pre-defined environment. Now, after we exit and another user is asking the server to get into the environment, it will land in a different container that will be of his own. The second user will have a separate container, not that of the first user. It will have, you can check over here, the container ID of this user one was 138 and of the second user is 084. So they are totally different environments and of 2 different users. However, there are so many amazing benefits with this tool, but there is some limitations also. Let's talk about limitations now. Now let us suppose that user 1 over here exited from the current state. Now he has done some work in that container and wishes to exit for some time. Now once he exits and wants to connect to this same container again, this is not possible with this as of this environment, that version we are running of ContainerSSH. This is not possible as of now. The previous user will enter in a new container and will be losing all the work that he has done in the previous one. So this is a limitation of this ContainerSSH. Now, how this tool can affect my client so that the cost can be saved and effectiveness can be increased. See, when we talk about containers, the containers will only take up the resources of the host server that are required. It will not reserve any kind of quotas or any kind of resource requirements. It will only use those resources which are extremely important. If we talk about Kubernetes, they also has a resource quota and will not go beyond what is mentioned in the configuration files. So this is how we can save our cost and resources, and also we can save our costs. Among other benefits, there is another benefit of ContainerSSH and containers, that applications running in containers can be deployed easily and are easily maintainable. So this is another benefit of using containers as a service. Experimental Saturday, we have covered the architecture of ContainerSSH, its use cases, and how the client can be benefited from this too. I have been extremely benefited from the initiative of Xenonstack, that I got this opportunity to learn a tool that is of different task I perform for my clients. I have been given this opportunity to present my work also. Thank you so much.